chapter 31. This chapter will contain information about graphs and related diagrams. First, we need to know what frequency diagrams are. So, let's start off by knowing what a frequency table is. We should know that statistics are usually concerned with the collection and organization of data. Therefore, using a frequency diagram is a simple way to represent those data. Here's an example of what a frequency diagram will look like. The first column is usually the name of the categories that we are researching into. The second is the tally, which is a way for us to keep track of the value of certain groups. And the third one, it has a similar function to the second column, but it is either to see what the value actually are. Group data. There are situations when data covers a really wide range of values. Therefore, it will be a hard task for people to interpret those. As a result, the solution to this is to put them into groups, which are called classes or classes intervals. This kind of diagram is called a group frequency table. And here is a group frequency table. So let's do some practice. There is some information related to the marks of 36 students in a certain mathematics exam, and they want us to construct a frequency table using groups of 10 to 20, 21 to 40, and so on. The first step to solving this kind of question is to draw the frame of a table and insert the headings in, which are marks, tally, and frequency in this case. The second step is to list the classes in the order in the column labeled marks, which is 1 to 20, 21 to 40, up until 100, which is the maximum point that a student can get. The further step is to use the information which has been provided to count up the tally. So we will count up all of these scores and then plot it in this table where each value is adequate to. Then the final step is to enter the result into the frequency column, which are right here, accountable for 36 students. B. What was the most common interval of marks? So this question is even more simple than the first one because all we need to do is to go to the third column, the frequency one, and then evaluate and see which one is the highest. In this case, we can see that 11 is the biggest one and it is allocated to the group 41 to 60. Therefore, we can conclude that 41 to 60 is the most common interval of marks. This is chapter 31.2 about pictograms. So first of all, pictogram is a way of representing data which is much more easier to interpret than a normal diagram like the frequency diagram because it has a visual aid such as pictures or symbols for us to visualize the information better. So in this case, the data is displayed using the human symbol to represent the number of students. So let's do some practice. This is a pictogram taken from a Sun Tours brochure showing the average daily hours of sunshine for 5 months in Tenerife. A. Write down the average daily hours of sunshine for each month. Really simple. We only need to know what the pictures represent, which in this case 2 hours per sun symbol. In May there are 5, June 6, July 6, same for August, and September also have 5. Using that we have 5 times 2 equals 10, 6 times 2 equals 12 for June, July, and August, and September, which is the same as May because it has 5 symbols. B. Suggest a reason why pictograms are useful in holiday brochure. One of the reasons are the visual impact. It really strikes the information straight to the reader's perception, so it will be easier and quicker for them to understand.
So here, 31.3, we will talk about bar charts. What is a bar chart? A bar chart is a series of bars of the same width, and they are drawn either horizontally or vertically. The height represents the frequency, and here is an example of bar chart. This represents the average amount of money And here are some notes about drawing bar chart. Both axes should be labeled, and the bars are separated by equal space. You must include a key to identify the two set data. To compare two sets of related data, it's much easier to use a dual bar chart. And here's an example of dual bar chart. You are comparing the period 1 and period 2 of 14, so it's easier to compare the score between two teams, and it is easier to see the difference between period 1 and period 2 and the difference between 14. In 31.4, we are learning about pie charts, another type of charts that is very useful too. Pie chart is useful when there are only a few categories and there's a big difference between the frequencies. And the whole data is a circle. It don't show the frequency, it only shows the proportion. Here's an example of pie charts. The name is favorite snack food, and it shows the proportion between cake, chocolate, fruits, and chips. But different way of paying. I will show you how to draw the pie chart. Here's an example. First, you're going to draw a table of frequency, and then you transform the frequency into angle by finding the percentage and then multiply with 360 degrees. And then you draw the pie chart by a protractor.
This is chapter 13.5, Scatter graphs. Scatter graph is a method of comparing two variables by plotting their corresponding values on a graph. The variables are treated just like a set of x and y coordinates. The first property of a scatter graph is correlation. Now look at this graph. You can see that as the height increases, the arm span also increases, so this one is a positive correlation. While you can see on this graph, while the h increases, the value decreases. This one is called negative correlation. On the last graph, you can see that as the distance from work increases, the wage could decrease or increase. So there are no overall trend. This is called zero correlation. The second property of a graph is line of best fit. Now a line of best fit is a straight line that goes between all the points on the scatter diagram, passing as close as possible to all of them. You should try to have the same number of points on both sides of the line. A line of best fit can be used into estimation. So now we will do an example. The table below shows the result of a science experiment in which a ball is rolled along a desktop. The speed of the ball is measured at various points. Now A said, plot the data on the scatter graph. So the first pair is distance from start 10 and speed 18. So we will plot here. B said, draw the line of best fit. So there we go, we have a line of best fit that goes through almost all of the points. C said, if the ball speed had been measured at 5 cm from the start, what is it likely to have been? So first we have to draw a straight line from 5 cm to our line of best fit. There, and we can see that the line crossed our line of best fit at about 18.8 cm. D, estimate how far the ball was from the start when its speed was 12 cm per second. Now we draw a line from 12 cm per second, and we can see that it crosses our line as about 32.5 cm.
In today's lesson, we talk about histograms graph. So first of all, comparing histograms and bar charts. You can see they pretty much kind of the same. On the left hand side, we have the bar charts, and on the right hand side, we have the histograms chart with like a table labeling its value. So the histogram has been drawn from the table. As you can see that the columns are not labeled 0, smaller and equal to t smaller than 4, and so on, as they would be on the bar chart. Instead, There is a scale on the horizontal axis. The first column is drawn between 0 and 4, the second is between 4 and 8, and so on. Moving on with it, we'll go straight to the 3 differences between histogram and bar chart. The first one is there are no gaps between the bar and histogram graph. The horizontal axis has a continuous scale in histogram graph. The area of each bar represents the class or group frequency of the bar.
Chapter 31.7 is about histograms with bars of unequal width. Histograms with bars of unequal width. So data and frequency distribution can be grouped into classes with different intervals, and this results in histogram bars with unequal width, basically. So the area of the bar represents the frequency of the class, so what is the value, how much is in the class. The height of the bar represents the frequency density, which we will cover in a bit. The frequency density is equal to the class frequency divided by the width of the class interval. So that is the class interval down there. It is 113 to 124. That is the class frequency, and that is the frequency density, the height of the bar. So here's an example. Calculate the class frequency of the class with intervals 113 to 124. So step 1 is to find the frequency density. By looking at the height of the bar, we can already see that the frequency density is about 0.45. Step 2 is to calculate the class width, which you just take the larger number and subtract it by the smaller number, which will give you 11 in this case. Step 3, multiply the frequency density with the class width. So you will get a class frequency of 4.95.